So this question is about sequence and series and trigonometry. So the way the sequence work here, it's built out of a right angle triangle. Now, what happens with this sequence is that, well, each of them have a right angle. So each of them have a right angle, but as well the main part or the second part of that sequence, that each time this side will have length of 1. The other two sides will change. So the first part in C is saying, are any two triangles in the sequence similar? Justify your answer. So we need to know what is similar triangle. So similar triangle, basically, kind of, if we can think about it, doesn't matter what triangle we take, right? So that's our starting triangle. We enlarge each side, let's say by, I don't know, by 2, each side by 2. And therefore, we have a bigger triangle. All angles inside will be the same. That's the main feature of similar triangles. And the side will be in ratio to each other. And that's what that ratio is. If we enlarge it by 2, each of them is enlarged by 2. That's the main idea, that they have the same ratio, the corresponding side. Now, in our case, the triangles, what changes is the two sides. This side change and this side change. So in the next triangle, those two would be a different length. However, every time one of the side doesn't change length. And because of that, no, none of the triangles will be similar, because in order for them to be similar, for two triangles to be similar, each side have to be different. They cannot be the same. If that is 1, then this one here cannot be 1. Will have to be bigger. So that's the reason why there is no similar triangles. Now, part D has something more to do with the sequence. So we have the kth triangle. So some triangle, maybe 10th triangle, maybe 100th triangle in the sequence, has a hypotenuse length of square root 41. And then where k belong to n, why? Because terms in the sequence are a whole number. Term 1, term 2, term 3. We don't have term 1.53. Okay, so we therefore have to find the value of k. So it's about a hypotenuse. So let's consider our triangles and hypotenuse. As you can see it, that's square root of 2, square root of 3, square root of 4, square root of 5. Okay, so if I'm thinking about it, T1 is has a hypotenuse square root of 2. T2 has a hypotenuse square root of 3. T3 has a hypotenuse square root of 4. That's where we see the connection, is the number of the term and the number that is changing. So therefore, we can conclude whatever that number is, this one will be plus 1. 2 plus 1, 1 plus 1. So following the same logic, if I have term, let's say 100, when that will be 101, isn't it? So if I have term k, well, therefore that will be k plus 1. Okay, so we have the first part figured out. So let's go back to the information we are provided. So 5 square root of 41. So here, well, the whole number is under the square root. So how can I get all that number under the square root? So how can I write 5 as a square root of what? 25, isn't it? Yes, you're right. Square root of 25 is 5. So I have square root of 25 multiplied by square root of 41. Now, if you didn't know, that actually means here multiplication sign. I know it's not written there, but that's what we have. So what can I do here? When you have two square roots like that with different numbers multiply, you can write them under one square root and multiply. So that means that is 25 multiplied by 41. And then if we put that in the calculator, we get is 1025. And since k, since we understand that here we have k plus 1, so that means that the value of k is what? 1024 plus 1 will become 1025. So yes, K is 1024. That's how we got our number.